Hey, Master Explorers, welcome back to FindXYZ, the place where we think, find, and shine. If you have ever wondered how scientists write numbers like the distance to the sun or the size of an atom without stressing, then you are in the right place. Today, we are diving into the world of writing big numbers and extremely small numbers. I call it the superhero of number writing. Now, can you guess the distance between the Earth and the Sun? That is over 150 billion meters. Imagine trying to jot down this number every time. Now let's dive in the opposite direction. Can you also guess the diameter of a hydrogen atom in meters? How small do you think the diameter is? It's just 0.0000000. Can you guess the number of zeros? 106 meters. That is 11 decimal places. Writing such small numbers can be just as tricky as writing the larger ones. So, is there a faster or easier and reliable way to write such numbers, either extremely large or very small? Absolutely. And that is what we are going to explore today. Scientific notation, commonly known as the standard form. But before we start with scientific notation, let's start with place value. I call it the backbone of our number systems. The ones, the tens, the hundreds, all the way to millions. Each step is a power of 10. This is what I mean. Now, if I ask you how many ones are in tens, you definitely tell me 0. How many tens are in 10? You definitely tell me 1. So you realize that each step is a power of 1 ahead. So this will be 10 to the power of 2. And in that order, millions will be 10 to the power of 6. Why is this useful? You'll find out very soon. Now, what is standard form or what is scientific notation? It is a way of expressing a very large or very small number as a product of a number. What is the name of that number? It's called mantissa or significant. That is between 1 and 10. 1 is inclusive but 10 is exclusive, and the power of 10. Now this is the format. Since it's written as a product of a certain number called mantissa or significant, a product and a power of 10, now the mantissa must always be between 1 and 10. 1 is inclusive but 10 is exclusive, and n must be an integer, that is a whole number. It can be positive, it can be negative, it depends on the direction that you are moving, or the number, the size of the number. Why is it very important for us to write numbers using the scientific notation or using the standard form? Firstly, it helps us to simplify writings of very large or very small numbers. You realize that if I ask you to write 150 billion 20 times, it will be a lot of stress. So simplicity. The next thing is that it saves time and also prevents mistakes. Imagine scientists recording the size of an atom, writing a lot of zeros. 1 0 omission can change everything. So with a scientific notation, it will prevent all these mistakes. Let's start with our first example. We have a very large number. The number is 454 billion 3 million. We are asked to write the number in a standard form. What is the first thing you do? Now we have to move the decimal point to the left of the number until we reach a number that is between 1 and 10. So once we get there, how many decimal places do we move? 11 decimal places. Because we move the decimal places to the left side of the number, the left side of the number, the exponent will be positive. So now we have 4.543 times 10 to the exponent 11. Now someone may ask, why is it that we are not writing the trailing zeros? Why didn't we add it? Now you realize that before the start of this video, I told you that this number, the first number, is called the significant. Now it's called a significant. The first number is called a significant. Trailing zeros are not significant. So trailing zeros in the whole number with no decimal places is not significant. So we can't write them. Even if we write them, it will be useless because they are not significant. That is why this mantissa is also known as the significant. But if the zeros come between two non-zero digits, you have to bring the zero. One thing I also want to add is that whenever you are writing a scientific notation, you are not changing the number, you are just expressing the number in another way. Example, if you have 5 cedis and you exchange it into 1 Ghana cedi coin, 5 of them, the value is still the same. It's still the same 5 cedis, but it's just different way of expressing the 5 Ghana cedis. Somebody can pick 2 cedis and 1 cedis. It's still the same 5 cedis. So with scientific notation, we are not changing the value of the number. We are just expressing a number in this format as a product of a number and a power of 10. All right, now let's try our second example. This time we are going to work with a very small number. We'll move the decimal places till we get a number that is between 1 and 10. 1 is inclusive but 10 is exclusive. So let's move 1, 2, 3, 4. We are there. So how many decimal places did we move? We moved 1, 2, 3, and then 4. But this time you realize that we are moving in the opposite direction. The first one we move to the left. The first one we move to the left, but this one we are moving to the what? The right. And right means that our exponent must be what? Negative. Our exponent must be negative. So what do we have? We have 4.789 times 10 to the exponent negative 4. Another thing that probably you might be confused right now is why are we not bringing the zeros in front of the 4? Now, leading zeros are not significant. They are just placeholders, right? As I indicated earlier. But if the zero comes between two non-zero digits, you have to include it in the mantissa. Now, let me give you some few tips that will help you not make errors when writing scientific notation. Now, if the number is large, example 10 or more, you are definitely going to move the decimal point to the left. And when you do that, the exponent must be positive. So large numbers means positive exponent. And then when you have a very small number, because you are going to move to the right, so small numbers like numbers between 0 and 1, you move the decimal point to the right, and then the exponent becomes what? Negative. This way you can easily convert any number into scientific notation. Large numbers move to the left, the exponent is positive. Small numbers move to the right, the exponent is negative. Easy, right? Okay, so let's do some small activity. Now try converting your birth year, your date of birth, the year, or your phone battery's capacity into scientific notation and post it in the comments. I'll be checking. Alright, I have some guests for those of you that partake in this activity. Alright, so thank you for exploring with me today. If you found this helpful, hit the like button, subscribe, share with all your friends. Don't be greedy, okay? Don't be selfish. Just share, okay? Sharing is caring. Share with your friends. This is FindXYZ, where we think, find, and shine. See you in the next adventure.